about the population, and we're going to talk more about with this chapter 19. We're going to talk about population demographics and dynamics and how we can measure things. It's quite interesting. How do we actually know how population is changing? So when you think about what a population is, it's just a group of individuals in a particular species in a given area. So this is an example of the human population of the United States, and it has all the different counties, parishes, whatever districts. Every state calls it something different. But you can see like they're more dense areas. So here, see where we're living. You see the I-35 corridor, the Houston area, how dense it is on the East Coast and the West Coast, and then you see the big rural areas in the middle and the West and the Midwest. But you can see that, you know, this is just a population. You see that certain areas are going to be more populous than other. Now, one thing that we do study is how these populations change over time. And one way that we can do that is by using life tables. And we'll have an example of a life table later on, but these detail life expectancy, and they use these to help set insurance rates. So one thing you think about is this population. You know, people associate Florida with a bunch of people going there to retire. So, you know, people expect maybe life expectancy won't be as long compared to maybe those people in California. You just never know. Now, one area of population ecology is to study the dynamics and how they interact with the environment. So this is quite interesting to see how that will change how things are going long term in certain areas. Now, there are certain things that you'll see. We'll have what we call the population size. It'll be shown as N. This is just the number of individuals in an entire population. And density is the number of individuals in a given area. So this one, the more dark blue it is, the more dense it is. They don't have the scale on this image, but you've seen on other images, the darker it is normally indicates a more dense population. Now, what population tells us, it gives us information about the status of the population. Sometimes if population is increasing, maybe it has the best conditions for that. Now, if a population is increasing, it depends what type of population you're talking about too, because, you know, if we're talking about endangered species, yes, we want to see those come back because we don't want to lose them. But if it's an invasive species, those are bad. You don't want those. You don't want to see that population increasing. That's why the fire ant, you don't want to see increased populations of fire ants. Those are bad, painful. So how do we estimate population size? So we're going to have to take samples. So sampling is where you just count all the individuals in a total habitat. And it's very hard to do because you're just estimating. And there's different ways you can do it. Because it also depends on the type of organism that you're sampling. If they don't stay still, that can be just quite difficult. That's why on one of your movie nights, you're watching the video where they're sampling an ant population in the forest. It's how do they go through and do that? It's quite interesting. That's why I selected it for you. Now, quadrant studying, these are best for those immobile organisms, plants, key into this category. I used some quadrant research in my master's program. So what you do is you have this big block right here and you mark off squares, and then you take random samples throughout here, and then you use that to kind of go through and determine like a sample population. Now, another way that you can do that is mark and capture. So this is where you capture organisms, mark them, and then release them, and then you recapture them and use that to help estimate population size. This is a little bit more better for those mobile organisms because, you know, you're not going to get something to say, you know, in that little grid. It can be quite difficult. So the mark and capture, it kind of is going to vary with the habitat and animal of interest. Think about, I always love to watch, like back when Shark Week used to be educational, where they would tag sharks, you know, so they can actually track them. It's really helpful because sometimes you can actually get migration patterns, and we're getting better with these tags, and they're putting like GPS technology in them, and you can actually see like, or with whales and stuff, and where they all go. So, you know, this does have some benefits to that. Now, when you go through this mark and recapture to determine like a population, there are a few things you have to think about. You want to make sure that you give the animals time to resettle before you go back and recount the population, but you want to make sure you don't allow too much time for the birth and death rates to be super impacted. And then when it comes to it, they have this equation that they can use to determine the population using this technique, which is the number of animals marked in the first catch and the total from the second catch over the total marked in the second catch. And that will determine their population size. Now, there are some things you have to assume with mark and recapture, and animals can be quite smart when it comes to that. Now, you're assuming that the population is going to remain constant between marking period and the capture period, like no natural disasters, big changes happen to make your population adjust. You're thinking that no individuals left or came into the population or were born or died. You're assuming the population is kind of at a static stance at that point. You're assuming that the chance for capture is the same each time, and that can be quite tricky because, as I put right here, there's no guarantee you're going to get the animals again. They can get kind of smart and know now how to not get caught. I always put like, a little raccoon. Or if there's food involved, you might get them as a sucker every time. So you need to make sure that you're considering different factors. One thing with the mark and recapture, you got to make sure that whatever you do use to mark them, it's not going to affect their survival and that it actually stays on the animal. So there's a lot of different things you have to think about when it comes to this technique. Now, when they're going through and looking at population, one thing we do love to look at is how it's distributed in a different area. And this might have a kind of clues about the type of species or the type of organism it is and how it's adapting and utilizing the environment. So there's 3 different types of species distribution that you can come across. The first one's clumped. So this is where you're going to see all the individuals of a population more in a big cluster together. And you'll probably see this if the abiotic factors are clumped. So they're showing elephants here. They always go in a herd. It's for protection also, so they can protect the little young ones from the hyenas and the dingoes, or I don't know exactly what are the lions. Yeah, that's the scary stuff that happens. But maybe it might be clumped around a water source, depending on what type of environment it is. You can have random. So this is where individuals of a population distribute at random. Plants are a prime example, especially those that rely on wind for distribution of seeds. Depending how it blew that one day, a bunch landed here, but then one here, one over there. And then you could have uniform dispersion. This is where all of them are dispersed equally. Everyone wants their own little space bubble. They're using an example of penguins. If you ever watch any of those nature shows and they show penguins, especially those big old colonies down there, they're all everyone's kind of, looks like it's really crowded, but everyone's kind of got their own little space bubbles. So there are different things you have to think about when you're measuring population, and it all comes down to what the input and the output is. So overall, your total population is going to be your input plus your output. So basically, your inputs are going to be your birth rate and your immigration rate. So new organisms coming into the population that were already living. Now, your output is going to be your death rate versus immigration rate, which is organisms leaving. Now, like I said, your population could be a positive growth or it could be a negative growth. It just depends which has the greater number. And sometimes your population growth can actually be 0. As I mentioned, the book talk about life tables. This is one example that the book has about the Dall Mountain sheep. And basically, this just gives you some information about life history of a specific organism. You'll see it often broken up by years, and sometimes you'll actually see it broken up by sexes, so male and females. Like I said, this is actually used to kind of help determine what life expectancy, and the insurance industry uses this a lot because they want to see what's the probability of them making it to the next birthday, probability of the young of this population actually making it to adulthood, and then that might determine how many young they have in each season. It's you can get a lot of information from these tables. And the book does talk a little bit about survivorship curves in this section, and I just want to introduce those 3 different curves that you might see. Now, basically, the curve that you're looking at is the number of individuals surviving. It's in a log base. and then the maximum life expectancy. And what they looked at with different populations, they see three different types of curves, and they kind of group them into type 1, type 2, or type 3. So type 1 is where you're going to have very few offspring and the parents have good care. So you're going to see the life expectancy expect to be long. And the number of vigils, will only go down once you reach like the maximum life expectancy because the care is so good. You're not going to lose a lot of young early on. So humans, animals in zoos, they're prime examples of this. Now, type 2 is where you have a constant mortality through life. There's nothing really going to affect it. It's just a constant decline over time. It's just a 50-50 shot if you're going to make it all the way to the end. Birds and rodents are good examples that they throw in right here. And then finally, the third one is your type 3, where the earliest stage is the highest mortality. So they're using a type 3, they're talking about trees right here. So early on, most of them are going to die off. But once you make it to about right here, the percent probability of dying off early goes down. Marine invertebrates also fall into this category because they have a lot of offspring because there's a good chance a lot of them aren't going to make it just past like a certain stage. So the more young that you have, there's a better chance of a few of them going out and surviving. So not much on that. It was a shorter section of the chapter, but here's some review videos on that. And then, of course, credit to the images.